continue our lab VXLAN multi-tenant, and we are focusing on the centralized route leaking. The centralized route leaking have three scenarios. One, the host routes communication between different tenants on the same leaf, and the host routes communication between different tenants on the different leaves. A host communication with another host in different tenants through external network. And we will leverage import and export RT attributes to achieve the route advertisements in different tenants. A centralized route leaking uses default routes for traffic goes to border leaf nodes. Every VIF in each leaf has to be configured route leaking using the leaking RT attribute. Host routes on local leaf does not leak on its own leaf nodes. Redistribution of the HMM is needed. At different VIF routes on the local leaf node, it routes to centralized border nodes through a default route and then forward it to the border nodes. Routes the traffic as a row table on the border nodes. In this diagram, we'll be focusing on DC2. This DC2 we already have is a tenant tenant 1, and what you will be seeing is the tenant 1 host right here. And we're creating a tenant 3, and we are host connected to the leaf 1 also. So this the scenario, we have two tenants on the same leaf. This tenant 3 will be able to route the default route using the default route to go to the leaf 1, then the spine 1, then the border leaf will be making this as a border leaf, the rootback interface 666, and route using a default route through an NAT to the internet. It will be connecting the DC WAN, and here will be a OSPF route leaking into the BGP to the VXLAN EVPN into the tenant 3 network. So in the DC2, we'll be focusing on creating a tenant 3 for the tenant 3 clients to the border leaf and to the internet. This will be the lab 1 requirement, border leaf 3 internet. So let us create a tenant 3. Let's move on more to my DC2 leaf 1. We'll be creating VLAN 300, name VNI13, and VN segment will be 10300. I'm creating another VLAN 310, name is L2VNI223, 10310, VLAN 333. So it's our L3 VNI. VN segment 333, 33. Show run VLAN. What we are creating, we're creating our VLAN, 2 layer, 2 VNI, and 1 is L3 VNI. Then we'll be creating is VIF context tenant 3 RD auto address family as IPv4 unicast, route target both auto, and I will generate RT value for EVPN. Exit and the VNI 33333. It's a L3 VPN VNI. So show run via app tenant 3. We have been creating tenant 3 VRF. We just created tenant 3 VRF. We'll create VLANs. Next, we will be creating is the interface for NXOS gateway. Interface VLAN 300, no shutdown, is VRF member tenant 3. IP address 192.168.3.254/24. Fabric forwarding mode and cast gateway. We're creating another VLAN 310, no shutdown. We have member tenant 3, IP address 192.168.3.254/24. Fabric will be forwarding mode and cast gateway. Lastly, our VLAN 333, no shutdown. We have member tenant 3, no IP redirect, IP forward, because this is the L3 for VXLAN VNI. So let's show run interface. This time we create VLAN interface for the tenant 3. Tenant 3 has 3 VLAN interface, VLAN 300, VLAN 310, and VLAN 300.333. This is the L3 VNI for VXLAN forwarding. And we'll go to my MVE1 and member is VNI 10300 MCAST. This will be a multicast forwarding 225.1.1.3 member VNI 10310 MCAST 225.1.1.31 and exit will be member VNI 33333 associated will be VRF. Show run interface MVE1. We created a VNI member and we assigned the memcast address. And VLAN 33333 will be associated VRF for L3 forwarding. And lastly, we are creating the EVPN. EVPN was assigning to VNI L2 VNI RT value. So first we're creating for 10300 RD auto and root target both auto and exit VNI 10300 L2 103.110 RD auto root target both auto. Don't want to forget is to enable the interface E13 no shutdown. First switch access VLAN 300. Next, we shall move on to my border leaf, DC2 border leaf, DC2 border leaf, Stockholm. And this time, our copy paste where we have configured everything here. Alright, we have copied over everything we configured except the interface 1/3 to DC2 border leaf. The next we'll go to is the DC2 spine 1. DC2 spine 1 will also be forwarding VXLAN 333 for Tenant 3. So, but it doesn't have any Tenant 3 endpoints connected, will be only as a forwarding. VXLAN, VLAN 333, name is VL3 VN93, VN segment 333 and exit VIF contact tenant 3 RD auto address family IPv4 unicast route target both auto route target both auto EVPN VN9 333 and we'll be making as L3 interface VNI 333 and node interface VLAN 333. Okay, so node shutdown VF member is 10 member is tenant 3. No IP redirect. IP forward int face MVE1 member will be associated VNI 333 associated VF. This is all we're going to configure on the DC2 spine. We configure the router cloud WAN device. Router cloud WAN device is having two interface. Show run interface G03 that's connecting to my DC WAN. Each has a just simple IP connection, nothing else. And we should have interface G00, our testing machine in the internet cloud. This the internet cloud customer Windows WAN device. Next, I'll move on to my DC2 WAN. The DC2 WAN is having interface G/02. It has IP to the WAN router, and we configured IP NAT outside. For the inside, we configured a interface facing the border leaf. Border leaf we have is IP NAT inside, and now is OSPF interface. For the OSPF, we configured is the OSPF. I will just network the direct connect interface to the WAN router, and we send default routes. Default routes were configured right here. is defer route to the cloud WAN router. So that's we simulate the cloud internet. After telling you how we configure the cloud internet, we'll move back to my DC2 border leaf. The DC2 border leaf will have interface. The interface is the E1/2. So interface E1/2. No switch, no shut. We have member tenant 3. IP address 128.61.0.130. So this interface already configured. We don't mind that, and do IPOS for the network. DC border leaf based on per BIF lit DC2 border leaf connects to the WAN router or the WAN edge. So let's bring up my border leaf at DC2. First we'll configure is the interface E1/2. No switch. We have member is tenant 3. IP address. Or configure OSPF. Ping. Okay, the interface, direct interface that is pingable. Next, we'll make a few roadmap for redistribution between the OSPF and the BGP. First, the roadmap we'll make is RMAP BGP to OSPF. Permit 10 will match route type all the IGP routes. Let's next roadmap we just leave it empty that will match any OSPF routes. Then we'll do BGP 200. We have tenant 3 address IPv4 unicast, and we have to network the different routes. And we have to redistribute OSPF to BGP. Show around BGP. We are enabling. We have the tenant 3 address family IPv4 unicast. We network our default route, and we'll redistribute the OSPF, all the OSPF routes to the BGP. All OSPF will be a default route. The default routes will be redistributed into the BGP to the other leaf. Don't forget to do OSPF, router OSPF1. Still query we have light tenant 3 will redistribute BGP 200 roadmap RMAP BGP to OSPF. That will make the routes VXLAN routes to the cloud WAN. And I will summarize what all I have, because I have many clients in Tenant 3. I'll just summarize routes, slash 24 routes. So let's take a look. Show around BGP again. We're redistributing OSPF to BGP with default routes, make it into other leaves through BGP and show around OSPF. We're redistributing all Tenant 3 routes to OSPF. This goes to the WAN edge, DC2 WAN, and we'll summarize all Tenant 3 routes. All routes ends to DC2 WAN, and we're not propagated to Cloud WAN because they are just static routes to each other. And if we leverage IGP to the WAN, it needs to redistribute OSPF into BGP. That's what we do. If leveraging eBGP, if there's eBGP, it doesn't have to redistribute because IGP populates it to the eBGP automatically. The IGP here. There are many ways to use the route maps. Master route type internal is one of them. You could also use the tags. At this time, we will go to DC2 WAN. And we want to show IP route we are getting. Summarize the route OSPF external routes into the DC, right? This is for Tenant 3. And if I go to DC2 border leaf, I show IP routes we have Tenant 3. I can find that default route right here in my routing table, right? So my DC2 leaf is getting a default routes from the OSPF. If I go to my leaf 1 and DC2, I will see if the default routes are populated. Well, first to show IP routes, we have the Tenant 3 in this database, the routing table. We're getting it from EVPN. EVPN and default routes. Next hop is the border leaf. This is my final IP route table. I want to show you is this default route getting through the VXLAN EVPN. So it should be VPN, V4, unicast, we have Tenant 3. We're getting this through eBGP VPN, right? And we'll go to DC2 spine 1. Similarly, what exists the one in my IP route table. So IP route VF Tenant 3. I have default routes in there also. So BGP VPN V4 unicast VF Tenant 3, and we'll see default routes, and I have SAS host routes as a client in Tenant 3. The next what we'll do, we'll make DC2 WAN configure NAT address translation. So let's do it and do a copy paste. I'm making a few translation here, static, all static, show IP NAT translation, show IP NAT translation, has three static translation. One is for the this one is for static translation for my client right here. So let's just scroll over to my client. It'll be DC2T3XP. DC2, okay. Show IP. This client's name and tenant 3. I'll just ping the customer WAN 63. And I could ping it. Also can trace it. And you can see the routes, how this route my internet traffic from the tenant to the internet. And I go to custom Windows, show IP. If I go ahead ping the translated IP address, which will be 122.61.0.252, and I can see I can ping the IP also. The traffic will be routes like this way. We first go to the WAN clouds, DC WAN, and the border leaf. The border leaf eventually goes to it goes to the spine 1 through the EVPN to the leaf 1 and the client, the antenna 3. So this all summarize how we make border leaf 3 use internet is a centralized route leaking to the internet into the tenants.